Now let's look at what's probably the simplest form of logic, and it's what is often referred to as Boolean logic. Okay? So in Boolean logic, we make use of some logical connectives. Right? And those logical connectives that we'll use here, we'll see some more later, but for right now, these will be limited to these: negation, conjunction, and disjunction. Okay? So as we saw in the last video, we'll represent statements or propositions. Okay, statements will be represented by letters. To understand how each of these works, though, what we're going to produce are what are called truth tables. Okay? So our first one we'll look at is negation. So negation reverses the truthfulness of something. Reverses or flips of a statement or proposition once again. Now how do we write it? So if my letter is A for my statement, one way to do it would be to put this apostrophe on it, which is what we're going to do. Some people do it like this little flipped sideways L. Some people do it like this. This is how you would do it in some programming languages for certain things. And some people would do it like this with a bar over it. So this is the one I'm going to use. So if we're producing a truth table for this, then I would say that here's A, and here's A naught. That's how I would say it. And so if A happens to be true, then the reverse of this would be false, right? And if A was false, then this would be true. So if I had something like this, A was equal to the sky is blue, then A naught is the sky is not blue. Right? So this is a unary. It applies to one thing. A unary connective. The other two we'll look at, the conjunction and disjunction, will be binary connectives. So we'll look at the next one, conjunction. So what this one means, it's a way of combining things. So combine statements. Using and. We would use that word and. So now we'll have two things, because I said this was binary, so it takes two things, just like a binary operator, just like 1 plus 2. Plus there, or addition, is a binary operation. So let's say our two statements were A and B. And so what are the possible combinations of truth values? Well, they could both be true. First one could be true and the second one false. The first one false and the second one true, and then they're both false. So here we're going to use this symbol. Okay, there's some others, but this is by far the most common when we're talking about logical connectives. Okay, and this also scales. So when these are both true, this is true. But if anything in the set of ands is false, then the entire thing is false. All right? So what do I mean by that? Well, you might have something more complex. You might have this, A and B and C and D. So this right here is only true if every one of these is true. Now there's 16 different ways to combine the trues and falses here. Okay, so I can have true, 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 false, true, true, false, true, and so forth, all the way down to false, 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 false. This is the only one that would be true. If any of the other 15 has a false in it, which they will, that's what the other 15 are, then they would represent an overall statement that is false. Now let's look at disjunction. Combine statements using the word or. So our truth table for this is this. This thing, it looks like a V, or sort of like a V. Is the symbol that we typically would use. So once again, we have true, 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 false, false, true, false, false. Right? Now when we're talking about or, only one of these needs to be true for the whole thing to be true. So true, there's a true, there's a true. The bottom one is all falses, so it's false. And just like up here, this scales. So if I had A or B or C or D, the only one of these that would be false would be all these. So this right here was really true and true and true and true. This is false or false or false or false. Now, this right here is an example of what we call an inclusive or, as opposed to an exclusive or. Exclusive ors, well, we can go ahead and look at that while we're here. This is an inclusive or. If we have an exclusive or, that's typically written like this, where it looks like a circle with a plus in it. And this symbol gets used in different areas of mathematics. You often see it in places where it's some operation that's not widely used, and so people need some symbol to come up with representing that particular thing. So like always, you have to be careful of what you're doing and pay attention to context. So here we have true, 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 false, false, true, false, false. Now with an exclusive or, and it's only here really for binary things, that this would be a situation like if you have a fork in the road. I'm going this way, and I can go left, or I can go right, but I can't do both. With an inclusive or, then they could both be true. Okay? Here, only one can be true. So true, true is actually false. True, false is true. False, true is true. And false, false is false. I can't have both be true and the whole thing then be considered true. Okay? So now if you've programmed, you've seen at least those first three. So let's do this. So in the C programming language and the Python programming language, so in C, we have a logical and. Python, we just use the word and. In C, we have two vertical bars. Here we use the word or. And here, we have the exclamation mark. Here we say not. Okay? But these are all logical operators in these programming languages. Both of these languages also support what are called bitwise operators, which have ands, ors, and nots, but that's not what we're talking about here. So these are the ones that typically you would see in something like this. In C, like we said earlier, you might have something like this. You might say if X and Y, then do something. In Python, this would be if X and Y colon, then do something. Or we could use or I might say in C, this is the C version, if not X, do something. In Python, we would say if not X, do something. So that's where these are getting used, and these support not the exclusive OR, okay? These support what we were calling and, or the backtick here. Is that backtick, or that would actually, well, that'd be an apostrophe actually. The apostrophe here. These are the logical connectives that we're looking at so far. Okay? We'll see some more connectives in a future video, but these are the basic ones, and these are associated typically with Boolean values. And in fact, in Python, you have variables of type Boolean. So you can literally say something like this. In Python, I can say X equals capital true, and it knows that X is a variable of type, what it would say is bool, if you were to check. So if I have variable X, if I type this, type, parentheses, X, in this case, it would say it's of type bool. Okay?